Hello again, everyone. Nostradamus here again, reporting for duty. Here's watching the live pictures from La Palma. Every 15 or 20 minutes ago, we're getting a loud boom. So it seems to be getting more explosive as time goes on. But I'm not here to talk about La Palma tonight. I want to talk about another volcano that you've probably never heard of, because I've never heard of it before today. And it may also be about to spring into life. Udecam Volcano consists of pyroclastic cones 2,180 metres above sea level. It's in southeastern Russia. Its current status is normal or dormant, for the time being at least. The Udecam Plateau volcano is a volcanic field located in southeastern Russia, 400 kilometres east-northeast of the Baikal Lake. The field contains cinder cones, lava domes, lava flows, and explosion craters, or Mars. Bump up the volume. The latest eruption took place at Shepe Volcano about 2,200 years ago. So, should we zoom in a bit and have a closer look? And as you can see, we've had two recent earthquakes, and they're only about 10 miles away from the ancient centre of the ancient volcanic field. Obviously, because it's been over 2,000 years since it last erupted, it's been well weathered, and it's very difficult to make out any volcanic craters or anything, but you can just make out a circular pattern around where the centre is, if you look closely and squint a little bit. There's a little bit more about its history, and it says that the last eruption before that one was about 8,000 years ago. But we've had a couple of sizable earthquakes. Yesterday, Wednesday, the 22nd, a 5.2 earthquake, and it was reported at 5.5 by one report I did see. And just today, it's the 23rd, we've had a sizable 4.6. Just north of the ancient volcanic field. So is that one about to erupt? It's all going on. Now this should get your attention. It certainly got mine a little after 1:15 this afternoon. Imagine my surprise when I saw this reported by Volcano Discoverer. A magnitude 9.5 megaquake, a great earthquake, at La Rioja, Argentina. Bloody hell. Look at the latitude on that, 66.6. I took a couple of screenshots. I'm glad I did, because it disappeared after about a couple of hours. It was up for a good 2 or 3 hours before they took it down, and nobody else reported on it. Well, they've got magnitude 9.5 at a depth of 649 kilometres, deep down under the crust, and lists the epicenter as Departamento de General Juan F. Quiroga, La Rioja, Argentina, and it lists the nearby towns and cities. And there was actually 2 or 3 felt reports of violent shaking. I don't know whether they was just winding them up or not, whether there was genuine reports. La Rioja is also a wine growing area in northern Spain. I bet there's plenty of Spaniards hitting the bottle now on La Palma. So, you know me, I'm a bit of an inquisitive chap. So I found this website, Antipodes map, because I wanted to know what was directly on the opposite side of the planet to this phantom supposedly 9.3 megaquake in La Rioja, Argentina. And if you stick your head in the ground in New York and travel a direct straight line through the centre of the earth, your head will pop out just to the west of Australia, and it says you're in the water and all you need is a boat. So let's type in La Rioja and see what comes up. Here we are, sticking our head into the epicentre of this 9.5 earthquake. And where do we come out? Oh, central China. But not just anywhere in central China. Let's zoom in. And where does that bring us out? Well, you really could not make it up, because that city there, just a few kilometres to the east, just a few kilometres, not many, just happens to be Wuhan. Yep, you heard it right. You come out in Wuhan. So there's one or two things happening here. Either somebody's messing about and putting 9.3 deep megaquakes on the map just for a laugh, or China has developed and tested an earthquake war machine. So I guess we'll just have to watch the western coast of South America for extremely large surface quakes over the next week or so. They're making all sorts of wonderful technological advances in Wuhan, you know. Today, I started thinking about one of me theories that I came up with a while ago, and I documented it in an old video. And it was during periods of solar minimum extended, and we had the mini ice age and the Maunder minimum and all that, and everywhere went, the northern hemisphere got really, really cold in some areas. And I put it down to, if the sun's quiet, more cosmic radiation comes in, and that destroys methane in the atmosphere. So we lose a bit of the greenhouse gas, and that's what causes the cooling. But it turns out I was completely wrong, because I've had a closer look at it. I decided to look in detail whether there was any correlation between methane concentrations in the atmosphere and the solar cycle. On our world in data, and the annual reports didn't begin until 1978, and the data's a bit sketchy beforehand. So we've got a yearly figure from 1978 up to the last year's average. And what I've done is I've recorded the annual change in methane levels from 1978 onwards. So it was 1553 in 78, and in 79 1550. So that was an increase of 17 parts per billion for that particular 12-month period. So this resulted in this graph. When from 1979 up to 2020, this is the annual change of methane concentrations. And it was pretty high during the 80s, and I think this is due to high pollution levels before they put a stop to a lot of the pollution that was going on. It came down, and then of course, as I've been reporting on for 2.5 years now, we've had a steady increase, enormous increase last couple of years, but we've been on the increase since 2004. There's been a few years there where it actually decreased on the previous year. Before I go on to the next bill, I just would like to note that 1991 we had a big spike, and I think that is due to the effects of Mount Pinatubo, because it's a bit odd, doesn't fit the rest of the graph. So we don't know how it affected methane levels. I don't think it actually released methane, but I think it had something to do with how it affected the degradation of methane in the atmosphere. This is showing the solar cycles over the same 41-year period. The solar cycles 21 and 22 were very strong. 23 was a little bit weaker. As we know, the previous solar cycle 24 was very weak indeed. So this is what you get when you superimpose one of these graphs onto the other. Now I'm going to disregard the solar cycle in the early 80s, because I think the high methane levels are due to excess pollution. But you can see how the methane plummets after the onset of solar cycle 22. Then Mount Pinatubo goes off, but it comes straight back down again. And then as the sun goes into its minimum, the methane levels start to rise again until we get to the beginning of solar cycle 23, where it comes straight back down again. And then since the end of solar cycle 23 and all the way during the week solar cycle 24, methane has been on an endless rise. So what does it mean? Well, I now think that during periods of heightened solar activity, i.e. more sunspots, more solar flares, more energetic particles entering the Earth's atmosphere, causes a greater destruction of methane molecules in the atmosphere, which is why we see the methane drop down during strong solar cycles. And as solar activity drops, then less methane is destroyed. Its half-life increases, It stays in the atmosphere longer, so overall levels go up. And this is completely the opposite of my original hypothesis. But yet it does make sense. It's all part of the natural order of things which helps keep the Earth's climate in balance. Or at least it did until we came along. So the sun's output grows, methane drops. Sun's output drops, methane levels increase, which helps to keep the overall average global temperatures nice and stable, no matter what the sun's doing. I hope you like that. It's definitely something to ponder on. Now it's time for the odd one out round. Can you spot it before time runs out? It was, of course, opportunity. The connection between them all are windows. You can go out window shopping. You can happily just use Windows 10 if you're so inclined. You can go out and hire a window cleaner. But the window of opportunity disappeared long, long ago. Here's a record of the past 24 hours of solar activity that, as you can see, we've had 2 sizable M-class flares. Ooh! I've been a busy little beaver today. On top of everything I've been doing, preparing this video, I managed to take in one of Paul Beckwith's video, where he's reporting on the state of the climate in 2020. This is the annual report from the Bulletin of the American Meteorological Society, volume 102, number 8, released last month. And by God, it's a meaty publication. I've only glanced through it. I'm going to try and read the whole thing and pick out things that of interest to me and share my own thoughts on some of its contents. I'm gonna leave the link to this in the comments box. If you want to peruse it yourself, I could not possibly go over this. It's going to take me a week a week or two just to read through it. It's so detailed and fascinating insights as to latest trends in all sorts of things regarding the perils that we're in. This is just the table of contents. Global climate, global oceans, the tropics, the Arctic, Antarctica, the Southern Ocean, regional climates, and you can see how many pages is devoted to each subtopic. There's just so much to delve into. The one thing that's grabbed me so far is the change in the salinity of the ocean in the North Pacific. I mean, that is just absolutely crazy. And I'm not going to go into it now. I'm gonna go through this article bit by bit, and I'll report on things one at a time. And if you don't read it yourselves, I'll bring things to your attention that's in the report, and I'll share my thoughts on things as they come up. I just want to add, I do think this is the result of the beginning of the stratification of the oceans as the global ocean currents beginning to shut down. Right, may as well finish off where I started, back at La Palma. Here's a very, very pretty picture of the earthquakes. Another pretty picture of the earthquakes. Seismic activity. This is showing. Let me just change me thingies just so I can fit it all on the screen at the same time. So he's showing the earthquakes. So the purple one is the latest one. That red one, red squares. Oh, that's a bit of an outlier. That's away from the others. What does that mean? Square, between 1.5 and 2.7, that one. So you get a 3D representation of how deep the earthquakes were and the orientations. It's the last 3 days. You see the red ones are the most recent and the blue ones are the older ones. So you can actually, it's like a visual representation of the magma movements, how they've moved beneath the ground from east to west upwards. I think it's cool. Keep going. Anything else interesting on here? No, that's about it. Well, that's it for another video. Thank you very, very much for watching, you lovely, lovely people. I would say stay safe, but I'm not going to say that anymore. I'm going to say get out there and live life to the full while you've still got the chance. You never know what's just round that corner. Adios, amigos. Ta-da!